Welcome dear students. In today's class we will discuss about the concurrency control and recovery. Concurrency control is a procedure in DBMS for managing the simultaneous operations without conflicting with each other. Database transactions are performed concurrently without violating the data integrity of respective databases. Now we will see the problems associated with the concurrent execution of a transaction, loss updates, uncommitted dependency, non-repeatable read, incorrect summary issue. The following are the different concurrency control protocols and these are the log-based protocols. Here I have listed two protocols such as two-phase locking protocol and timestamp based protocol. Here lock is a variable associated with a data item that represents its state with respect to the operations present in the transaction. The first protocol is two-phase locking protocol. It is also abbreviated as 2PL. In two-phase locking protocol mechanism, the transaction should acquire a new protocol only after it releases all its previous locks. And this locking protocol divides the execution of a transaction into three different phases such as growing phase, locked phase and shrinking phase. Here we can have a variation of two-phase locking protocol as strict two-phase locking method. This strict two-phase locking method never releases a lock after using it. That means it holds all the locks until the transaction is committed. Once the transaction is committed, then only it releases all the acquired locks. Strict two-phase locking protocol can be divided into three types: centralized 2PL, primary copy 2PL and distributed 2PL. The second type of concurrency control protocol is timestamp based protocol. It serializes the execution of concurrent transactions. That means this protocol ensures that every conflicting read and write operations are executed in timestamp order. This protocol uses the system time or logical count as a timestamp. Let us consider one example. Here we have three concurrent transactions T1, T2 and T3. T1 has entered the system at the time 10. T2 has entered the system at the time 20. T3 has entered the system at the time 30. The priority will be given to which transaction? Yes. Here the priority will be given to the transaction 1 because compared to the T2 and T3 it arrives to the system early. Hence the T1 gets the first priority followed by transaction T2 and T3. The next mechanism is the checkpoint. It is a mechanism where all previous locks are removed from the system and stored permanently onto the storage disk. Checkpoint declares the point before which DBMS was in the consistent state and all the transactions were committed. During recovery, we need to consider only the most recent transaction that started before the checkpoint and the transactions that started after the TI. Let us see the recovery process. The log will be scanned in backward direction from end of the log to find the most recent checkpoint record. The scanning process will continue in the backward direction till a record TI start is found. It needs only it needs only the part of a log following above the start record. The earlier part of a log can be ignored during recovery process and can be erased whenever we decide. For all transactions with no T commit, execute undo. Scanning the log in forward direction for all the transactions starting from the T or later with the T commit, execute redo. Thank you.